Hello and welcome. I'm Elizabeth Hausler, the founder and CEO of Build Change. I'm delighted to welcome you today to the launch of our cost study, the cost of improving vulnerable housing, recommendations for investments in housing resilience from an analysis of global project data. Build Change and partners have completed thousands of retrofits and home improvement projects around the world, and we're thrilled to share the findings. Before I turn over to Build Change's VP of Engineering, Lizzie Collins, who will guide us through today's program, I wanted to provide some context on what we mean when we discuss the costs of improving vulnerable housing and why we're publishing this report today. At Build Change, we overcome the three major barriers to adoption of resilient housing, PMT, or people and policy, money, and technology. Money or access to financing has always been part of Build Change's theory of change and model, because we know that if people don't have access to their own resources, to a grant or to a loan, they won't build or retrofit a disaster resilient house. So strengthening housing must be cost effective. We can have all the building codes, trained engineers, and engineering expertise in the world, but without money, without access to financing, home improvement plans will stand still. So we're here today to demonstrate that it is affordable to improve existing housing. It's not as expensive as you may think. Plus, it provides opportunities to make not only improvements to withstand disaster, but also improvements that impact daily lives, such as fixing leaky roofs or improving kitchens and toilets. Which is the first point I want you to take away. Improving vulnerable housing is not as expensive as you may think, especially when compared to rebuilding new. It is possible to make existing houses more resilient to disasters, both before and after disasters, for less than many of you probably think. My colleague Lizzie will guide you through exactly what those numbers are and the benefits of making those investments before a disaster, whether it's a fire, an earthquake, a hurricane, or a flood, better than waiting until after. The second takeaway is about access to housing finance. You'll hear today about the cost of improving vulnerable housing based on decades of Build Change's experience, tens of thousands of families we've worked with around the world. While many homeowners are fortunate enough to have the resources to make improvements themselves, many of our clients need the support of grants and loans to strengthen their houses. What this means is that governments, philanthropists, microfinance banks, and other banks must make investments to continue to support affordable, resilient housing for all. These investments, not only in the materials and labor needed to strengthen a building, but also in the systems for widespread implementation and programming, enable efficiency at scale, which is needed if we are to make resilient housing a reality for all people worldwide. Thank you so much for joining us today. Now I'd like to introduce my esteemed colleague, Lizzie Collins, Build Change Vice President of Engineering, who will present some of our key findings. Lizzie?
Great. Thanks so much for kicking us off, Elizabeth. I'm going to go ahead and share my screen. Great. I've had the pleasure of overseeing the analysis of this cost data and the preparation of this report, and I'm excited to share what we found and what it all means. Essentially, following the implementation and development of hundreds of home improvement designs by Build Change from Asia, the Caribbean, Latin America, and the Pacific, we've compiled and analyzed the data to understand the cost of home improvement and how spending is allocated across different kinds of interventions, specifically structural condition repairs, habitability upgrades, disaster mitigation measures, and finishings and growth. The cost data was compared across different building typologies, hazards, contexts, and structural performance objectives. And the costs were also compared to the relative cost of new construction. The data you'll see highlights many reasons why preventatively improving existing housing for health and for safety before the next disaster is not only crucial, but a smart, cost-effective investment, including compared to the alternative of building new. We know that adequate housing is a human right and that inadequate housing Adequate housing is a human right, and inadequate housing or vulnerable housing is disproportionately inhabited by the poor, putting those who are already vulnerable most at risk when disasters strike. UN Habitat estimates actually that about 40% of the world's population, or around 3 billion people, will be living without adequate housing by 2030. And that's just 8 years away now. Improving existing housing is a critical path to changing that and creating more resilient housing. Investment in better, safer, healthier housing must be prioritized to protect people and assets against ever-increasing threats. Yet we find that one of the common barriers to homeowners, governments, funders, and others who could invest in improving existing housing is a lack of information or a misunderstanding about the associated costs. This home improvement cost study was undertaken in order to share key information and trends about the cost of improving existing housing. We wanted to look at what is money being spent on and how is it being directed across different types of improvements. We also wanted to understand how do these costs compare across different contexts or scenarios, different building typologies, hazards, and performance targets. And we also wanted to look at the cost effectiveness of home improvement relative to new construction. We drew upon a data set of nearly 1,500 designs from Asia, the Caribbean, Latin America, and the Pacific. Approximately 300 designs were determined to be representative of these different designs and were grouped into 75 different design groups. The data set covers 14 different countries across 4 regions. These include Indonesia, Nepal, and the Philippines in Asia, the Commonwealth of Dominica, Haiti, and St. Martin in the Caribbean, Colombia, Guatemala, and Mexico in Latin America, and the Cook Islands, Samoa, Solomon Islands, Tonga, and Vanuatu in the Pacific Islands. Representative samples in each design group were averaged across the group so that each of the 75 design groups was weighted equally in the data set. It's also important to note that the cost data analyzed as part of this study includes specifically the direct construction costs of home improvements, including structural, non-structural, and other construction costs like demolition. Non-construction direct costs such as technical assistance, permit fees, etc., or other indirect costs such as relocation costs or financing are not included in these numbers. Additionally, the data for this study was collected over 8 years, from 2013 to 2020. And so all costs were adjusted for inflation to 2020 US dollars. I want to talk a little bit more about the design groups. Design groups consisted of sample designs that shared key characteristics such as location, building typology, performance target, hazards considered in the design, and the context. Sample designs within the same design group were averaged to get an overall representative set of costs for each group. So for location, this was one of the 14 countries listed above, and in some cases, this was further refined by region or city. The existing building type included different types of building typologies. These were defined by parameters such as the number of stories, the type of the roof, the construction materials, and the structural system of the building. The majority of building types included were masonry or timber houses of 1 and 2 stories, like the existing houses shown on the screen. The mitigation performance target. This was the level or standard to which the building was retrofitted to improve the disaster resistance. This consisted of either risk reduction, which was comprised of bespoke changes to mitigate risk through reducing vulnerability that do not otherwise target a specific performance level, to life safety, which is a full retrofit that enables the building to meet the required hazard intensity levels defined by the relevant building code. And then also life safety plus future vertical expansion. And this was a life safety retrofit that included the provision for a second story, whether that second story was built concurrently or left for the future. We also looked at hazards addressed. This is the design studies considered either earthquake hazard, high wind hazard, or in some cases both, depending on the applicable hazard for the location. And we also looked at context. For designs that were developed following a disaster in that location, the context was considered post-disaster, while for designs developed for locations that had not previously or recently been affected by a disaster, the context was considered prevention. To better understand what the money was being spent on, the cost of improvement was divided into 4 main categories of spending, which were identified built change through our experience in housing improvement programs. The first category we consider was structural condition repairs. These are items that require repair or replacement due to damage from past events, insects, or deterioration, like repairing or replacing a damaged or cracked masonry wall or damaged roof framing, or replacing timber elements like beams and rafters that are rotted from moisture or deterioration due to insect infestation. Another category we looked at was habitability improvements. And these are items that require to meet basic health and safety standards, including accessibility requirements. These types of actions are things like improving lighting and ventilation by adding windows or window wells in interior courtyards, upgrading electrical or sanitation systems. It also could be improving access to water or adding a new toilet or a new septic system, or potentially including partitioning spaces that improve interior distribution or improving egress routes. A third category was disaster mitigation measures. And these are items that are specifically added to mitigate the risk of building collapse or other life-threatening hazards in the event of an earthquake or windstorm. Examples of this include adding ring beams to the top of masonry walls or continuous top plates to the top of timber walls in order to brace the wall and tie them into the rest of the house. It could also include things like enhancing the connection of an existing roof framing and the way it's connected to the walls to better resist wind pressures. The fourth category considered was finishing and growth. And these are action items that were desired by the homeowner or occupant, often forward-looking in their use of the house. This includes things like interior finishing, adding a drop ceiling, or applying wall finishes like plasters and painting. It also includes converting elements to more permanent structural elements or implementing horizontal and vertical expansions to enlarge the house. I'd like to spend the rest of the presentation highlighting the key findings and the resulting recommendations for investment in more resilient housing. The first key finding was that improving existing housing is substantially more cost-effective than building new. On average, across the data analyzed, the cost of improving existing housing was only 23% of the average cost of building new housing of the same size in the same locations. By using what we have, we can make our resources reach so many more people. The average cost of improvements for all design groups was around $133 per square meter, and the average total cost of new construction for the same design groups was around $588 per square meter. This graph plots the average cost of improvements for all the different design groups as dollars per square meter. This is the shorter, thicker bars that you can see, with the cost of new construction for the same location shown by the thinner, taller bars. The horizontal dotted line shows the average cost of improvement across all the design groups, and the heavier dashed dot line shows the corresponding average cost of new construction of the design group. So you can see the gap between the two here in this plot. You can also see that design groups are arranged group by performance target from risk reduction to life safety plus future vertical expansion. And there's also labels placed on the data for the hazards and context, so you can get a snapshot of the design group data across all 75 groups. Looking at the frequency distribution of the cost by design group, 39 out of 75 design groups, or more than half, had a total cost below $100 per square meter. Additionally, although there were some outlier groups, for 90% of the design groups, the total cost of improvement was below $250 a square meter. When only design groups targeting life safety are considered, which is a target similar to new construction codes, improving existing housing is even more cost effective, costing on average 21% the average cost of new construction. In other words, constructing new housing is almost 5 times more expensive than improving existing housing for essentially an equivalent level of disaster resistance. Therefore, investments in improving existing housing should be prioritized as a cost-effective means to address the gap in the global supply of adequate housing, as well as to help combat increasing threats due to climate change over time. The next finding is that in many cases, improving existing housing can be further leveraged to safely densify housing and cost-effectively create new housing units. Overall, improvements that included upgrading the existing house to safely receive a future vertical expansion were on average 35% the cost of new construction. These improvements may include work on the existing house, such as replacing a lightweight roof with a slab roof that can support a second level, or increasing the strength of the ground floor to account for an increased lateral loads due to the future expansion. We also found that in cases where the house was improved on the ground floor and a second floor was added as part of the work concurrently, the average additional cost associated with preparing for and adding the new space to the existing one-story house, beyond the cost of just the life safety improvement, was essentially equal to the cost of new construction for the same location. However, this does not account for the cost of land and site development that would likely need to be added to the cost of new construction, thereby making improvement plus expansion less expensive overall when compared to new development. There can also be some social or environmental benefits to safely densifying strategic urban areas instead of developing new sites. Therefore, investments in improving and expanding existing housing should be prioritized as a cost-effective means to support safe densification, particularly in urban areas. Another key finding was that home improvement investments address multiple challenges. Homes can be made more resistant to disasters while supporting other goals linked to increased household resilience overall. As discussed, interventions to increase the resilience of housing fall into four main categories: structural condition repairs, habitability upgrades, disaster mitigation measures, and finishings and growth. The kinds of improvements that Build Change supports are not just structural, but we also improve homeowners' quality of life. We take the whole picture of resilience in mind, improving the safety of houses, but also making houses a place where homeowners want to live and grow their futures. The starting point for these designs, all included in this study, was disaster mitigation and/or recovery. However, from studying overall spending across all the design groups for the four cost categories, we can see that while almost 60% of the home improvement spending was on disaster mitigation measures specifically, more than 40% of spending was in the remaining three categories combined. Our experience has consistently shown work in these other cost categories to be a critical component of home improvement work. And this is reflected in the high amount of spending in these categories overall as well. Whereas the need for disaster mitigation measures may not always be evident to or prioritized by a homeowner, the opportunity to add another bedroom, to improve the layout of the kitchen, or to increase security, for example, is often more an effective incentive to invest in home improvement. Therefore, investments in improving vulnerable housing should vulnerable housing should account for other improvements to the house beyond just disaster mitigation measures, based on what we know homeowners need and want. The next main finding is that improving housing before rather than after a disaster is a smarter, more cost-effective investment. Of the 75 design groups, 23 were in the post-disaster context and 52 were in the prevention context. From other studies, we already know that there are savings from preventative mitigation, such as that by the National Institute of Building Sciences, which identified a 4-to-1 benefit to cost ratio for retrofitting private buildings like houses. This study further showed that the cost of making a house resilient to disasters before a disaster is substantially less than after a disaster. This is exactly why we need multilaterals, governments, and philanthropists to invest so we can build better now. Figure 7 here shows that the average total cost of improvements for the post-disaster design groups was $176 per square meter. Whereas for the prevention design groups, this was only $113 per square meter. Costs were 1.6 times higher on average for the post-disaster design groups. And with the exception of finishings and growth, costs increased in every category in the post-disaster context, with the cost of structural condition repairs increasing by about 6 times. It should be noted also that the cost increases observed across almost all categories in the post-disaster context are likely to also reflect the rise in labor wage rates, material prices, equipment costs, and contractor profit that can result from demand surge following disasters. Looking at finishing and growth, the higher costs associated with that category in the prevention context is likely due to families deprioritizing them, not having enough funding for them, and then being less affordable in a post-disaster context, as well as in the prevention context, families having more to spend on these without the cost burden of substantial repairs or increased post-disaster market costs. And also families being motivated by these items to improve their homes in the first place. Therefore, investments in improving existing housing before a disaster, when is more cost efficient and enables more of the investment to be directed towards non-structural and forward-looking interventions rather than just repairs. Looking at the case study of Hurricane Irma recovery in St. Martin, which were houses that were designed for life safety performance in the post-disaster setting, we can further see why improving housing before rather than after a disaster is a smarter, more cost-efficient investment. There were 3 categories of interventions: a lightweight roof repair and retrofit, which was for houses with a lightweight roof made of timber or steel framing in which the roof was repaired and strengthened. And these had a lower level of damage due to the hurricane. There was also a reinforced concrete slab roof repair for houses with a reinforced concrete slab roof in which the roof was repaired. These also had a lower level of damage and deterioration. And the third category was when a new lightweight roof and ring beam was provided. And these were for houses with a lightweight roof made of timber or steel framing in which the entire roof was replaced. These had a high level of damage in the existing elements due to the hurricane, including also badly deteriorated reinforced concrete roofs, which were replaced with a new lightweight roof. We have 2 main takeaways from this. First, overall, we can note that when the roof could be repaired versus replaced, the total cost of improving the house was about 40% lower than the average total cost for houses that required roof replacement. This further highlights that preventing damage, both by ensuring the structure can withstand the applicable loads and by starting with quality construction materials and practices, ultimately saves money in the next disaster by avoiding having to replace and rebuild parts of it. The other key takeaway is that for the new lightweight roof and ring beam interventions, where the roof had to be completely replaced, we can see that the roof reconstruction is categorized as structural condition repair, as this work addresses the high level of damage to the roof in the hurricane. In these cases, the cost of additional disaster mitigation measures for the rest of the building is only 24% of the total cost of all improvement work, or an additional investment of approximately 30%. This additional cost is low considering such work can help mitigate against other threats like earthquakes and better protect the investment in the new roof and all other work undertaken to increase the building's resilience against future windstorms. Therefore, we recommend that in post-disaster settings, investments should go beyond repairing damage to make preventative home improvements that will protect the investment against future threats for a low additional cost. We also found that consistently, the cost of improving existing housing varies greatly depending on the level of performance targeted. Figure 9 is compiled considering a subset of data from the 2 countries where design groups from all 3 categories were available, which were Colombia and the Philippines. We see that on average, life safety interventions cost 17% more than risk reduction interventions, but 55% less than life safety and future vertical expansion. This means that improvement goals should be planned to fit the level investment available. Along the same lines, we also found that home improvement can be tailored according to the available level of investment. Taking a look at the example of the Philippines, we further examine the affordability of housing improvements. Similar to the larger data set, the cost of improvements vary based on performance objective. The average cost across all design groups and performance targets in the Philippines was $183 a square meter. Based on this average cost of improvements per square meter and the average house size of 50 square meters from the Philippines design groups, the average total cost of improvements for a home in the Philippines was estimated at $9,150. This cost was then examined alongside income and poverty data from the Philippines Statistics Authority to determine its affordability for households of different income levels. Income bracket A is the highest, while income bracket D and beyond are below the poverty threshold, meaning that these families cannot afford to fulfill even basic needs. At this cost per house, the higher income brackets would afford a loan and repay it within a reasonable time frame. But those just above the poverty line and below would not be able to reasonably afford it. However, if we consider specifically the average cost for a risk reduction improvement, which was $72 a square meter, or $3,600 for a 50 square meter house, this is more affordable. Income brackets A and B can pay back a loan within a year, and income bracket C would need only a 7-year loan. However, most microfinance institutions whose clients are in the lower middle income brackets prefer even shorter loan repayment terms of approximately 1 to 3 years. So Build Change has been working with these MFIs to help them provide incremental home improvement loan packages with lower costs that can be repaid over even shorter time by their clients, including those in income bracket C. It's important to note, though, that in spite of this, financial support in the form of subsidies or grants is likely to be required to make those home improvements affordable to families living below or at the poverty threshold, since they do not have disposable income to spend on loan repayments in any scenario. Home improvement should be accessible to homeowners at all economic levels, but this is only realistic through the right financial products combined with grants and subsidies. This is why at Build Change, we advocate for a systems approach. We need governments, banks, and philanthropists to make housing finance accessible to all. We need to ensure that the needed subsidy or grants can be provided to low income and poor households for improvements that may not otherwise be affordable. Finally, our last key finding that I'd like to share is that relative to the corresponding cost of new construction, there was no increase in improvement cost design for both earthquakes and high winds versus only earthquakes. In locations exposed to both seismic hazard and wind hazard, home improvement costs were on average 2.8 times higher than those locations exposed to seismic hazard. However, the cost of new construction in the locations exposed to both seismic hazard and wind hazard were approximately 3 times higher than those locations exposed to only seismic hazard. This indicates that the apparent cost increase for making homes resilient against multiple hazards rather than against a single hazard is likely due to the generally higher cost of construction for those markets. Both cases were on average about 1/4 the cost of new construction for the corresponding locations. Therefore, home improvement programs and interventions should take advantage of the high efficiencies of mitigating against multiple hazards to ensure that all applicable hazards are addressed when making improvements to reduce disaster risk. That summarizes our key findings and recommendations. You can read more about each in our full white paper at www.buildchange.org, Cost of Improving Housing, or for those of you who want less detail, there's also a summary graphic with the highlights on the same page. I'd like to now ask my colleagues to join us to hear some inputs from how the cost of improving vulnerable housing applies in our work. To moderate this part of the webinar, my colleague Tim Hart will join us. Tim has over 30 years of experience in structural engineering as an internationally recognized expert in confined masonry construction. He has been working with Build Change in one capacity or another almost since the organization was founded more than 17 years ago. Most recently, we had the pleasure of Tim serving as our Simpson Strong Tie Fellow for Excellence in Engineering over the past 2 years. Like many things the engineering team at Build Change has worked on over the years, Tim also contributed to this study. Tim, thank you for moderating, and I'll hand it over to you.
Thank you, Lizzie. Terrific presentation. Hello, everyone. Thank you for joining us today. So what we'll be doing here for the next few minutes is getting voices from the field. And these voices will enable us to contextualize. I mean, there's a lot of numbers that we're throwing out there. So now we're taking those numbers and actually contextualize them to how things are actually being done in the field, and how what we have experienced in our programs in terms of financing and with retrofitting and so on. So, and indeed, these voices are important for us. Indeed, it was concerns that were raised by our teams in the field that led us to that was the initial driver to conduct the study in the first place. So this was, important to us to address the needs and issues that our teams were bringing up to us, and that resulted in the study that we're rolling out today. So we'll first be hearing from Manuela Pinella Rodriguez. She is our country director for our Build Change program in Colombia. Manuela combines her training in urban development and international cooperation with her background in anthropology to take a human approach to solving social and economic challenges. Over the course of the last decade, she has worked on both the national and international levels to improve access to water for hygiene and sanitation, as well as in post-disaster response, land rights, and housing access. We'll next be hearing from Gurley Lopez. Gurley is our project manager for housing finance for our Build Change program in the Philippines. Gurley's passion is creating access for low-income families to financial services. While at Build Change, Gurley has focused on improving access to capital while also leading the scaling of national resilient home construction loans for the first time. Over the last 17 years, Gurley has been one of the Philippines' most foremost microfinance specialists. And at Build Change, Gurley oversees the scaling of housing finance loans through the organization's microfinance partners. And then finally, we'll hear from Leva Shrestha. Leva is our lead engineer for our Build Change programs in the Asia and Pacific region. Leva is responsible for controlling the quality of design information and implementation of our projects in our Southeast Asia and Pacific regions, including the Philippines, Indonesia, and Nepal. With 14 years of experience in the field of structural engineering, Leva has been involved in retrofits and confined masonry house designs, construction of school buildings, along with conducting research and testing programs, quality assurance, and quality control of design information, project implementation management, and activities monitoring. So with that, I'll start I'll invite our first speaker, Manuela, to talk about our program in Colombia. So Manuela, the cost of improving vulnerable housing is always a consideration when the housing projects are being subsidized in whole or in part by the government, as is the case in Colombia. Can you tell us a bit about how cost considerations have come into play in the interventions that Build Change has been involved with in Colombia, such as through incremental improvements?
Thank you, Tim. Yes, of course, the cost of improving vulnerable housing is the key defining issue in the housing policy in Colombia. So just as context, it's important to highlight that the home improvement policy and programming in Colombia is 100% based on subsidies. So you could say that it's a subsidy allocation policy. The second thing that is important is that, as in many other parts of the world, the home improvement policy and programming for the past decades has been traditionally focused only on habitability improvements. In the past few years, also thanks to the advocacy of Build Change, the housing policy and the home improvement policy have been changing and allowing structural improvements and resilient housing to be integrated into the policy. So right now we have a national program going on that includes structural improvements to make houses more resilient. And we also have some local initiatives throughout the country. But that doesn't mean that habitability is still not a priority for the policy and also for the homeowners. People still want to live in a dignified house with access to water and sanitation, with better kitchens, better floors. But structural improvements come to be more and more important. So what can we do? So the first thing is obviously that we have to combine these two things. We have to work on habitability and we have to work on structural improvements. So the answer that we have been finding in Colombia is an incremental approach to resilient housing or to structural improvements. So we see this, and I'm going to talk about two main cases. The first thing is in Casa Digna Vida Digna, which is the national home improvement program. Basically, the way that the government took the approach of incremental housing was with categorizing the home improvements that are part of the program. So they go from category 1 to category 2, and it goes incrementally in how do you include structural improvements, but still the subsidy amounts are limited. So that means that even in category 3, it's still not done. People still need to keep going further to make sure that the houses are stronger and are more resistant to disasters. So I'm going to talk a little bit about what we need, but this is a really important thing because it doesn't mean that it's impossible to do resilient housing with the money that we have. It's just that we need to take that incremental approach, making sure that we combine habitability needs with structural needs. And then we also have a different kind of approach, which is Plan Terrazas, which is a pilot program in the city of Bogota, the capital city of Colombia, that is looking for the first time to include strengthening informal housing in Colombia, in Bogota, but also making sure that these houses are expanded and the offer of housing increases in the city. So this Plan Terrazas is aiming to retrofit 1,250 houses, but also to making sure that they can be expanded vertically in the next few years. So the way that Bogota did was to combine different subsidies to increase the amount available to do this. However, because it's still working to expand houses, that means that incremental approach still needs to be considered, not only for the structural improvements, but also for that next steps of making sure that the house can be expanded and increase the opportunities that people have in this house to, for example, rent the second floor or to have a shop in the first floor and live in the second floor. So that leaves us with a way to go forward with resilient housing, but also with a need to make sure that homeowners have the capacity to do and to continue that incremental approach in their own way. So there is definitely a need to mix or to find ways to combine different financial schemes. So it's not just 100% subsidized, but we can also think about ways to make available money for homeowners through MFIs or through, like the financial system, or also through savings programs. And this is not new to Colombia because the housing policy for new housing takes this kind of combined mixed approaches to make sure that people can afford a new house. So it's a matter of thinking about how we can integrate that into the home improvement policy. So this is the case for Colombia.
Thank you, Manuela. That was excellent. So next question is for Gurley. So Gurley, we're dealing with a lot of trade-offs in this industry, whether homeowners will do all of the work now versus some of it now and some of it later, whether they'll choose to improve the habitability or do structural upgrades or both, whether they'll use their own savings or take out a loan to support greater upgrades, among many things. So can you tell us about how some of these trade-offs have played out in practice in our work in the Philippines and how you're working with financial institutions to help offset the risk?
Thank you, team. In the Philippines, although we are considered to be one of the most vulnerable countries in the world to natural hazards, still there's a good number of homeowners who are not really aware of the actual risk and their ability to mitigate said risk through strengthening the structure of their houses. Sadly, some, especially those in substandard housing, have accepted that there's a vicious cycle of their house being totally destroyed every time a strong typhoon comes or an earthquake happens. Thus, one of the vital components of Build Change's program in the Philippines is raising awareness about hazards, as well as their vulnerability and how they can mitigate said risk by making their homes resilient. This program component aims to change the mindset in the communities and at the grassroots level. Most of these are those that belong in the low-income household. And since we are targeting the low-income household who are the most vulnerable when a disaster strikes, we believe that the best way to work would be with the microfinance institutions who have the experience and expertise in providing financial services in the said market. Currently, we are working with our partner MFIs or our microfinance institutions to develop and implement an appropriate, sustainable, and scalable loan product for building disaster resilient houses. Actually, this is in our aim to help direct the investments to mitigate risk associated with substandard housing in the country. In the said program, we assess the existing structural health of the houses, and then we recommend upgrades, specifying to them the specific scope of work, and then providing them an estimate of how much each improvement would cost. And since we know for a fact that investment in homes or houses are major investment for families, for homeowners to decide to do it, it should be within their financial capacity. Others would opt to save money for this, but typically it would take some time. In most cases, it would take years, especially for the low-income families. For a low-income household who urgently need to strengthen their houses in order to keep their family safe and healthy, the other option is to borrow loans which they believe they can repay. And since affordability could be wide range, in this program, homeowners are given options to either one, construct a new house, or what most often they would choose is to strengthen what they currently have. They also have an option whether to improve their house one time or they do it incrementally in phases. Basically, to build the capacity of the financial institutions, we at Build Change have developed resources, training modules, and tools which they can utilize. Overall, the program in the Philippines right now aims to raise awareness on the need for disaster resilient houses and, more importantly, provide that access to the appropriate loan products that addresses the demand and preference of the homeowners themselves, and then seriously consider how much they could afford or want to afford. At the end of the day, the goal would be for the vulnerable homeowners would want, decide, and actually make their home safer this time around before the next disaster strikes. Thank you, Tim.
Thank you, Gurley. That was terrific. So our final question is for Leva. So Leva, in our study, we've talked about different considerations that should be made in balancing investments between post-disaster versus pre-disaster. So in the post-disaster setting, such as what we experienced in Nepal, investments should go beyond repairing damage to make preventative home improvements that will protect the investment against future threats for a low additional cost. But one of the major barriers to that is convincing owners that this kind of investment is needed. So can you tell us about how your team went about doing that in Nepal during the reconstruction after the 2015 earthquake?
Certainly, Tim. The epicenter of the Nepal Gorkha earthquake was in a rural, hilly region of Nepal. And it affected the rural area of Nepal more than urban centers. So, when you look at a typical rural Nepali home, it is a stone masonry house with 2 stories plus an attic. And this sort of house is necessary to support a farm lifestyle where
the ground floor is usually acts as a barn. The first floor would serve as a bedroom and living area, and the attic would serve as the kitchen and sort of a storage area for agricultural produce. So during the reconstruction, after the Gorkha earthquake in Nepal, cash grants were provided by the government for retrofitting, but it was much lower than what was provided for reconstruction. And homeowners could choose to either retrofit their house or to construct a new house. Now, with the higher granting available for new construction, homeowners who were listed under the retrofitting category were initially inclined to convert to a reconstruction beneficiary category. Although, technically a reconstruction beneficiary should demolish the existing house and construct a new one. Well, no one was really doing this, and it was sort of not enforced strictly by the government. So like when we look at the costs of retrofit a 2.5-story house, it is quite similar to the cost of cutting a very small one-room house, which is definitely not enough space for a family to support a farm-based lifestyle. When we look at the cost of retrofitting a traditional house, which would be typically around 110 square meter space, it would cost about $5,500 US. Now, if a homeowner were to construct a new house with this amount of money, he or she would get no more than 15 square meter of space, which is very small. Now, also we found that homeowners who had houses in marketplaces where the house itself was like a source of income for them, we found them quite more willing to retrofit the house, as they would have, like, since they were in the marketplace, they would have limited space, so they wouldn't have much space to construct a new house and still keep the old house. So they were more inclined to retrofit. Whereas, we found it more challenging to convince homeowners whose houses were further away from the marketplaces. Now, however, we found that homeowners are usually reluctant to make a huge investment all at once to retrofit their house, as for them, with that expense, they are not getting any additional space, additional physical space. So to encourage more homeowners to retrofit, an incremental approach definitely needs to be taken. I think it's similar to what we've seen in Colombia as well as Philippines, where the retrofitting intervention itself is sort of split into different phases, and each intervention phase means that the house is more resilient compared to what it was before, and this broken down cost associated with each phase is a lower and a relatively more affordable to the homeowners than retrofitting all at once. And the Nepalese government agreed that this could be a way forward to scale up retrofitting in rural Nepal, and this was also recorded as one of the lessons learned. Well, one of the biggest challenges to implementing retrofit was that retrofitting was a completely new concept for homeowners. They were familiar with repairing their house, but they found it difficult to believe that their house could be retrofitted to be more resilient to future disasters. Even local government, local builders, and even local engineers were not very familiar with the concept of retrofitting and the benefits of retrofitting, because it was not something that was commonly happening especially in the rural areas of Nepal. And when you look at like post earthquake, whereas there were like hundreds of organizations working to support new construction, there were only a handful of organizations supporting retrofitting. The information as presented in the cost study, I think such information can be used to not just inform, but also to motivate governments and donors and organizations to support retrofitting in not just in a post-disaster situation, but also I think in a preventative context in a place like Nepal. Thank you.
Thank you, Leva. So to sort of briefly summarize what we've been talking about. So there is a clear need to advocate for retrofitting and home improvements and to make those affordable and to make, provide adequate access to financing. It does require a lot of creativity and creative thinking in making that happen, including different ways of financing homes. We talked a lot about incremental retrofitting as one way to make it affordable. Another, also talking about integrating structural improvements with habitability improvements, since much of the programs that we see being implemented around the world seem to be focused more on habitability improvements, but getting structural improvements integrated into those programs is can be a challenge at times, but at the same time, it's greatly beneficial. It sounds like a daunting challenge, but it really is not. And that the creative, if we're creative and think outside the box, then we can generate, we can save a lot of money, and more importantly, save a lot of lives. So there's a need to communicate the risks. We're dealing with homeowners and financial institutions and even government officials who don't really understand what the level of risk is, or figure, as we've seen as Curly was mentioning in the Philippines, people just assume, okay, if the typhoon comes and wipes out my house, I'll just rebuild, start over and rebuild. So, being able to communicate that risk to a level that everybody involved, all the stakeholders involved can understand is an important part of all of this. And finally, there is a definite need to advocate that it is safer and more cost effective to strengthen a house before a disaster than it is to demolish and rebuild a house after a disaster. The houses, and I think, Gurley had mentioned this before, these houses are these families' most important asset. In some cases, it's their only asset. And oftentimes, as Leva was talking about, their houses are not just a place, their residence, but it's also their business. It's also, their entire livelihood. Their entire lives are wrapped up in this house and making sure that this house is safe. So being able to invest in that, in their house to protect it, is what is really an asset that it's a smart investment. It's a cost-effective investment. And, in the end, most importantly, it saves lives. So, that's the takeaways that I have. So we'll invite you now to tell us your takeaways and ask some questions. So I will turn it back over to my esteemed colleague, Lizzie Collins, who will moderate the Q&A session. Lizzie?
Great. Thank you so much, Tim, Manuela, Gurley, and Leva for those inputs and contextualizing some of this data in this study. We do have a few questions. And for those of you that may have questions that we don't get to address live on the call, please go ahead and reach out to us at advocacy@buildchange.org, and we'd be happy to follow up and answer any questions you may have. So we have a question. I like that that make aesthetic improvements in addition to resilient engineering. What is the biggest challenge in balancing the architecture and the engineering so that you end up with a holistic final product that is both resilient and beautiful? So I'll go ahead and introduce this, and then I'll ask our team if anyone else would like to add anything. Well, it really comes down to looking at the way we approach our projects, and that is a homeowner-driven approach. So we're looking at what homeowners need and want. They are in the driving seat of what happens to their house. And we look at how can we have safe buildings in a sustainable way with homeowners' satisfaction. And balancing those is challenging. I'd like to hear from Manuela or Gurley or Leva or Elizabeth or Tim, if any of you would like to contribute an example of when we've had to balance sort of the engineering with the homeowner demands and the aesthetics. Go ahead, Leva.
Thanks, Lizzie. I think one thing I would really like to share my experience implementing the retrofitting project in Nepal is, like I said before, we were sort of retrofitting these traditional houses where, this traditional architecture is sort of, part of the hillside, part of the aesthetics of the hillside as well as these were areas where there was a lot of homestay programs that were being carried out. So what we did was we designed the retrofit in such a way that it did not, we could maintain the traditional features of the architecture of the traditional house, but also we sort of advocated to the public that we embedded the features, retrofit structural features into the traditional architecture of the house so that the space, the use of the space and the look was not disturbed. And also we sort of connected a lot of, these homestay programs to how these houses were strengthened so they could, have an increased business in that regards. So.
Great, thank you, Leva. That's excellent. And Manuela, would you like to add something?
Yeah, just something very short and obvious, but I think it's about having a human perspective when you're working on home improvement and thinking about the people that are living on those houses. So obviously our approach in homeowner driven, that takes many forms, but just to put a recent example from the Plan Terrazas program in Bogota. So the first thing is that the government team that works on this is a multidisciplinary team. So it's architects, it's engineers, but it's also social professionals, so social workers, anthropologists, sociologists, to make sure that there is a way to relate to the people that is horizontal. There's a, like a one-on-one conversation with the homeowners and the people that live there, so we understand and they can talk freely about what they want and the expectations. And there's a negotiation that happens. What is the money available? What are the needs of the house according to the assessment? And then you have to come to an agreement. And once again, the incremental part of it is really important because families need to understand how they can continue to improve their house in a way that is safe, in a way that makes the house stronger and not, cause some damage in the house because you want to put a second or a third floor immediately. So it's just at the end, the home improvement programs, and it's not a technical program, it is a social program that is aiming to improve people's lives. So if you put them at the center, then that's how you make sure that everything is balanced.
Great, thank you, Manuela. Excellent. Let's see, I'll just address one quick question here and then save a couple minutes for closing remarks. So now that we have all this information, what are the next steps? Will Build Change be updating this study in the future? So of course, we would love to update this study in the future. This represents almost a decade of knowledge and inputs. And so as our opportunities grow to include more geographies and more typologies and things, of course, we'll look at updating this in the future as well. In the meantime, we hope that this information will continue to push forward and advance improving housing to make it more resilient and give people tools and resources to be able to do so. So I'll go ahead and wrap up the webinar now. Thank you all for the insightful questions and for the discussions. Today we've talked about where there are savings and areas for cost effectiveness, prioritizing prevention, making houses both habitable and structurally sound, and providing opportunities for expansion. But the need remains for making affordable finance accessible for homeowners so that they can have adequate resources to invest in their home improvements. By looking back at what our experience has shown us and sharing that, we hope to further a path forward with these lessons towards more resilient housing. Every year, Build Change designates a priority for the year. And this year is our year of money. How do we shape the financing investment environment to make resilient housing more accessible for a greater number of homeowners? Collaboration with governments, banks, and nonprofits can create or supplement home improvement finance markets and establish successful pathways for financing. So please join us in our mission to make resilient housing accessible for all. We will circulate the cost of improving vulnerable housing to everyone here today and look forward to discussing with you all further. Please don't hesitate to reach out with us, as I mentioned, at advocacy@buildchange.org with any questions or to follow up. Thank you.